From far beyond our solar system, an object is rushing through space that refuses to behave like anything we have seen before. Astronomers call it 3I/Atlas, the third interstellar visitor ever discovered, but nothing about it is ordinary. It formed its tail in the wrong direction. It switched on and began boiling off gas much farther from the sun than normal comets do. Even the light scattering off its dust breaks the usual rules. Wherever scientists look, 3I/Atlas seems to say, "I am not like the others." And the strangest part is not just what it has already done, but what is still coming. In December 2025, 3I/Atlas will reach a critical point in its journey, a moment astronomers around the world are already watching closely, because it may finally reveal what this object really is. Is it just an extreme comet shaped by an ancient and violent past? A time capsule from a star system older than our own? Or something far more mysterious, carrying the signature of physics or even technology that we do not yet understand? Even if you have already seen headlines or short clips about 3I/Atlas, most of them only show one piece of the puzzle. In this story, we will connect all of those pieces together, from its discovery to its bizarre behavior near our sun to what may happen next. Stay with this video until the end, because every time we think we understand 3I/Atlas, it breaks another rule. The story begins on a quiet night in July 2025. A network of automated telescopes in Hawaii, Chile, and South Africa was scanning the sky as usual. This system is called ATLAS, short for Asteroid Terrestrial Impact Last Alert System. Its mission is to find objects that might threaten Earth and give us time to react. That night, ATLAS picked up a faint, slowly moving dot against the background of stars. At first, it looked like thousands of other small objects, just another harmless rock orbiting the sun. But when astronomers calculated its motion, something immediately looked wrong. Objects that belong to our solar system follow a simple rule. The closer they are to the sun, the faster they move to stay in orbit. Earth travels at about 30 kilometers per second. Even Mercury, the fastest planet, stays below 50. This new object, however, was far out near the orbit of Jupiter in the cold outer regions of the system, yet it was racing along at more than 58 kilometers per second, faster than Mercury, even though it was much farther away. That should not happen if it were born here. A speed that high at that distance does not match a normal solar system orbit. An object moving like that is not bound to the sun in the usual way. It is passing through on a long, open path, briefly bent by our star's gravity before it continues into the dark again. This was the first big shock. The conclusion became clear. This rock was not one of ours. It had come from interstellar space, from beyond the invisible bubble that surrounds our solar system. As more observations confirmed its strange path, astronomers gave it a special label, an interstellar visitor. Officially, it became 3I/Atlas. The I marks it as interstellar. The 3 shows that it is only the third such object ever found passing through our solar system. And Atlas honors the telescope network that first realized it was not a normal member of our local family. Before 3I/Atlas, we had only seen 2 such visitors. The first was Oumuamua, discovered in 2017, a long, mysterious object that tumbled through space and moved in ways that sparked debates about whether it was natural or possibly artificial. The second was Borisov, found in 2019, which looked more like a traditional comet with a clear tail. Both came from outside our solar system, but they still fit more or less inside the range of behavior we understood. 3I/Atlas stood out from the beginning. In size, it is significantly larger than either Oumuamua or Borisov, with an estimated width of around 5.5 kilometers. That makes it more like a small mountain flying through space than a simple chunk of ice. In speed, it is more extreme, racing along faster than our previous 2 interstellar visitors. But then came the detail that made astronomers stop and stare: the way it chose to enter our solar system. Most of the material in our solar system, including the planets, asteroids, and many comets, orbits in a thin, flat plane like a spinning disk, with the Sun at the center. Oumuamua and Borisov both approached on angles that cut through this disk from above or below the orbital plane, crossing the orbital plane like arrows fired from different directions. 3I/Atlas, however, came in almost perfectly along the same plane where the planets move, as if it had lined itself up with the solar system's main highway. Its trajectory sliced through this thin disk in an incredibly narrow, well-timed line. Some astronomers compared it to hitting the bullseye on a cosmic target. To cross that particular plane at that moment on that exact angle purely by chance seems unbelievably unlikely. It might still be coincidence, but it's the kind of coincidence that make people wonder if there is more to the story. Once its path and speed were understood, scientists tried to answer a deeper question: where did this object come from before it entered our neighborhood? By running computer simulations and tracing its motion backward through space, some researchers suggested that 3I/Atlas may have been born in a very old part of our own Milky Way galaxy. Our galaxy has a thin disk where new stars are still forming, and a thicker, older component above and below that disk filled with ancient stars from an earlier time. Some estimates suggest that 3I/Atlas could be several billion years old, possibly around 7.6 billion years, which would make it older than Earth itself. At some point in the distant past, it may have been thrown out of its original star system, perhaps by a close encounter with a giant planet or by the violent death of its parent star. Since then, it could have wandered the galaxy for ages, looping slowly around the Milky Way, passing through vast, empty regions of space.
Calculations of its long-term motion hint at something even more remarkable. In all that immense time, it may never have passed as close to any star as it is now passing to our Sun. If that is true, then 3I/Atlas is not just another rock. It is a survivor from a time and place we will never see directly, making its first real close approach to a star in billions of years. And that star, by chance or by some deeper pattern, happens to be ours. When 3I/Atlas first crossed into the outer reaches of our solar system, it was just a fast, dark speck beyond Jupiter's orbit. At that distance, most comets stay frozen and quiet. They usually do not begin to change until they come much closer, where the sun's heat can start to vaporize their surface layers. But once again, 3I/Atlas refused to follow the script. When it was still around 5 times farther from the Sun than Earth is, it began to grow a faint, ghostly envelope of gas and dust around its core, something astronomers call a coma. For a comet to switch on and develop a coma at that distance is highly unusual. The best explanation is that 3I/Atlas contains large amounts of carbon dioxide, or dry ice, which turns directly from solid to gas at relatively low temperatures. Even weak sunlight out there was enough to make its frozen surface start to boil away into space, announcing its presence far earlier than expected. But that was only the beginning. As scientists studied this coma, the object became stranger still. They measured not just how bright it appeared, but also the polarization of its light, the preferred direction of light waves after they scatter off dust and gas. Most comets and asteroids show positive polarization patterns that fit well with what we have seen for decades. Even Oumuamua and Borisov behaved in that familiar way. 3I/Atlas, however, showed strong negative polarization, as if the scattered light were choosing almost the opposite directions to what is normally seen. The degree of this negative polarization was more extreme than for any other known object. On that chart, 3I/Atlas did not sit with the cluster of ordinary comets. It sat alone, an outlier, hinting that its dust grains or surface texture might be arranged in a way we have never sampled before. Spectroscopic studies added still more questions. When astronomers split the light from 3I/Atlas into its component colors and looked for chemical fingerprints, they detected nickel, a metal commonly found in cometary material. That was no surprise. What was surprising was what seemed to be missing. In most comets and asteroids, nickel and iron appear together because both are forged side by side in the hearts of massive stars and in powerful stellar explosions. At first, 3I/Atlas showed clear signs of nickel, but no matching signature of iron. Only later, as it came closer to the Sun and heated up more strongly, did iron lines finally appear in its coma. This suggests that its interior may be layered in an unusual way, with different materials released at different stages of heating, and that it may have formed in a star system with a very different chemical history from our own. Then came the most visually shocking behavior of all, its tail. Normally, when a comet warms up, material streaming away from it is pushed outward by the solar wind and sunlight, forming a tail that almost always points away from the Sun. With 3I/Atlas, early observations suggested that the tail was pointing toward the Sun, roughly in the same direction the object was moving. It was like seeing smoke blow against the wind. Imagine standing in a strong wind and feeling your hair blown forward over your face instead of backward behind your head. That is the kind of wrongness astronomers felt when they saw those first images. Later, as the object moved closer and conditions changed, its tail shifted into a more normal orientation, pointing away from the Sun. But that initial reversed tail remains one of the most dramatic and puzzling signatures of this visitor. Now, as 3I/Atlas swings around the Sun and begins to climb back out of the solar system, it is entering the final stage of its brief appearance in our skies. Around December 2025, it is expected to emerge from behind the Sun and make its closest approach to Earth. That moment will be our best chance to see how the intense heat near the Sun has changed its shape, its surface, and its activity. Has it become more like a familiar comet, settling into patterns we understand? Or will it reveal new surprises in its coma, its tail, or its light, forcing us once again to adjust our models? A few months later, in March 2026, it is predicted to pass near Jupiter once more. The Juno spacecraft, which orbits Jupiter, may be able to capture a final set of measurements from this encounter. After that, 3I/Atlas will be on a one-way path outward, leaving our Sun behind and returning to the deep interstellar dark from which it came. We may never see it again, and no other star may get such a close look at it for billions of years. So what is 3I/Atlas in the end? An incredibly old fragment of rock and ice, carrying the chemical memory of a star system we will never visit? A natural object that, by chance, breaks one rule after another, from speed to polarization to tail direction? Or something that will always sit on the boundary between explanation and mystery, a reminder that the universe still holds secrets far beyond our current understanding? Whatever the final answers turn out to be, this visitor has already shown us something important. Our solar system is not closed or isolated. We live on a small world circling an ordinary star in a galaxy full of wanderers we are only just beginning to notice. And some of those wanderers, like 3I/Atlas, refuse to behave the way we expect, forcing us to rethink our theories and hinting that the universe is far stranger and far richer than we imagined.